Welcome to today's WindowsNetworking.com webinar. WindowsNetworking.com is a trusted resource for Windows Network administrators, providing reliable information on how to set up, maintain, and troubleshoot Windows networks of any size. Today's webinar is sponsored by Kemp Technologies. Kemp is the #1 price performance load balancer and application delivery controller, used by thousands of businesses who consider IT, e-commerce, web, and business applications as mission critical to their long-term success. Kemp helps companies rapidly grow their business by providing 24/7 infrastructure availability, better web performance, and secure operations, all while streamlining IT costs. I'm the event moderator. My name is Roger, and I have a few quick housekeeping items to cover before turning things over to our speakers. The first of which is to let you know that we are recording today's event. All participant lines are muted, so if you are having any problems and need to communicate with me at any time, please use either the chat feature or the questions feature at the bottom of your control panel to send a question to the organizer or send me a chat, and I'll try to give you assistance. We highly encourage everyone to also use the same questions panel to submit any questions or comments you have during the presentations, and we'll collect those and have our speakers address as many of those as possible at the conclusion of the presentations. Our speakers for today are Richard Hicks, Bhargav, Shukla, and Kurt Jung. Richard Hicks holds MCP, MCSE, MCTS, MCITP, Enterprise Administrator, and MCSA certifications, and is a network and information security expert specializing in Microsoft technologies. As a 6-time Microsoft Most Valuable Professional, he has traveled around the world speaking to network engineers, security administrators, and IT professionals about Microsoft Edge security and remote access. Richard has nearly 2 decades of experience working in large-scale corporate computing environments and has designed and deployed perimeter defense and secure remote access solutions for some of the largest companies in the world. Richard is an independent consultant focused on helping organizations, large and small, implement direct access and client-based remote access VPN using the Microsoft platform. Bhargav Shukla is the Director of Technology, Strategic Alliances at Kemp Technologies. Prior to Kemp, Bhargav worked on multiple technologies helping Microsoft Enterprise customers achieve the most out of their investment in Microsoft products and platforms. Bhargav is a current Exchange MVP and holds MCSM and MCM certifications in Microsoft Exchange and Link servers. Kurt Jung is a senior research analyst at Kemp Technologies. He's part of the Strategic Alliance team at Kemp and acts as the technical lead on many of the partner-driven opportunities. Prior to joining Kemp, Kurt has spent most of his career working as a consultant, helping customers deploy technologies to support their business. His primary focus is around messaging and collaboration. And now I'll turn it over to Richard to get us started.
Thanks everybody for joining me today. I appreciate it. I'm really excited to be on the webinar and talking to you guys today about Windows Server 2003 end of life risks and considerations. I think to start the conversation, I kind of wanted to take a step back and talk a little bit about the support timeline for Windows Server 2003, talk a little bit about where it is, where it's come from, where it is, and where it's going, and actually where it is today. So Windows Server 2003 was, of course, first released to manufacturing in April of 2003. Fundamentally, that makes it a 12-plus-year-old operating system. Running technology for 10 to 12 years obviously comes with its own unique set of challenges, but moving on, we'll certainly talk about those as we work through the session today. The last service pack for Windows Server 2003 was introduced in March of 2007, so fundamentally the last major update to the operating system is now more than 5 years old. Microsoft, of course, ended mainstream support in July of 2010, and if you're not familiar with the Microsoft support lifecycle, Microsoft has 2 forms of support for their products, their operating systems and applications, that being mainstream support and extended support. So now mainstream support is the traditional support model that we're probably all familiar with. Microsoft produces security updates, they release hot fixes, you can call support and get things fixed. You can actually even put in what's known as a DCR in the Microsoft vernacular, a design change request. In other words, Microsoft in mainstream support may also implement new features and functionality as part of their normal support process for an operating system or application in mainstream support. Microsoft ended, essentially after mainstream support ends, it goes into what's known as extended support. Extended support stopped at the end of life for Windows Server 2003, which was in July of this year, so just a few months ago. The implications, there's a number of implications with regards to end of life for a product. So first and foremost, and probably the most obvious, is the fact that the operating system is no longer supported. What that means is that you obviously can't call Microsoft, ask them for help on Windows Server 2003. If you're running a workload on Server 2003, file and print services, web services, doesn't matter what it is, if you have a problem with it, essentially you're on your own. You are left to your own devices to try and troubleshoot that. The real challenge there, of course, is that if those issues require any sort of coding or any sort of fixes that need to be produced by Microsoft, those are not going to be addressed. Also, and I think this is a pretty serious challenge for any end-of-life operating system, Windows Server 2003 included, is that the operating system now is no longer being updated. Now, what that means from a support perspective is it means that there's not going to be any more hot fixes available for it. If there's anything that's broken, that's not going to be fixed. Also, it means that there's obviously not going to be any more further development. There's not going to be any new features coming out for that as well. And I think that the real challenge with this is mostly from a security perspective, because it leaves you, the customer, still running on Windows Server 2003 in a potentially perpetually vulnerable state. And what that means is this. After end of support and after end of life, again, Microsoft is no longer releasing any updates, even security hotfixes. What that means is that if a security researcher or an attacker finds a vulnerability in the Windows Server 2003 operating system, even if Microsoft is aware of it, they will not fix it. What that means, again, is if you are running a workload running on Windows Server 2003, and there's a vulnerability, it will not be fixed. You're basically exposed to a permanent zero-day vulnerability, which obviously is probably one of the worst scenarios that you can possibly have. That has some particularly challenging issues, and it's particularly troubling for a couple of workloads, and I certainly want to talk about those a little bit more later. Now, during this webinar, unfortunately, we only have an hour. And we could probably speak for days about all of the workloads that are new and improved in modern operating system in the latest release of Windows since Windows Server 2003 was implemented. But what I want to do is I want to focus on a number of key workloads today that are vitally important to today's computing environment. So the first of those being certificate services and PKI. If you're running a PKI on Windows Server 2003, support issues aside, you're missing out on some very important and some very key functionality, features, and capabilities that are going to be critical to supporting modern workloads in today's current computing environment. I want to talk a little bit about Active Directory Federation services. ADFS has been with us for many years now. It's becoming more and more heavily relied upon today in today's cloud-first world, as it were. So I want to talk a little bit about that. IIS has some unique and interesting challenges with regards to running on Windows Server 2003, so we'll touch upon that just a bit. I want to touch base and really talk a little bit more about remote access. So I am actually a remote access expert. This is one of the areas that I focus on, and I spend pretty much all of my time today consulting with is Microsoft Remote Access, and we'll talk a little bit about where remote access was in 2003 and where it's come today, some of the features that you might be missing out on. And then finally we'll talk about Hyper-V, and Hyper-V is a very interesting conversation because Hyper-V obviously didn't even exist in Windows Server 2003. So moving forward, let's talk a little bit about our certificate services workload. So if you've deployed Active Directory Certificate Services, or ADCS, on Windows Server 2003, the opportunity, of course, to move to a modern operating system that's supporting new features and functionality is obviously critical. If you're supporting 2003 PKI, you're probably already planning a migration because you've probably run into shortcomings and limitations of the underlying operating system. For example, Windows Server 2003 does not support any sort of modern encryption. So certificate service is really showing its age with regards to PKI support. There's no support for a variety of things like Suite B encryption, cryptographic next generation, SHA-256 certificate signing, and so forth. So a lot of these capabilities are going to be essential moving forward. Also, I think it's important to understand that you know, in the 2003 era, so at the beginning of the 2000s, PKI was is not very widely deployed, and of course, oftentimes the only thing we really needed certificates back in those days was for a public-facing web server, and often those came from, you know, third-party trusted CAs, for example, a VeriSign or a Thought or DigiCert or something like that. So the need and the real requirement for certificate services in the early 2000s was not as demanding as it is today. Now, we fast forward to today, of course, and you talk about you know, the widespread and rather pervasive spying by federal governments and the like. There's a real move on to basically just encrypt everything everywhere at all times, at rest, in transit, and certificates are going to be vitally important to meeting those particular requirements. Also, you know, certificate services was fairly new and pretty immature in 2003, and today's organizations are, you know, much larger. Mergers and acquisitions and things like that are, we find that multi-forest Active Directory deployments are pretty common, and of course, Windows Server 2003 had no support for any sort of cross-forest enrollment. It didn't support any sort of enrollment capability for web services. It had no support for device enrollment. So this was another real challenge, is that if you had network devices, things that were not Windows operating systems that wanted to request a certificate from a PKI, those were not supported. So really, if you're running Server 2003, you're missing out on quite a bit of essential functionality that you need in today's modern corporate computing environments. Also, another really critical and very key important factor with regards to modern PKI, and I'm talking about on the latest release of the Windows operating system, network operating system, Windows Server 2012 R2, is TPM key attestation. So TPM is Trusted Platform Module. That is a device that's running on most computers, or any computer running Windows 8 would have to have this. TPM is basically a hardware device that does two things. It stores certificates and their keys, and it also can perform cryptographic functions. TPM key attestation is a feature of Windows Server 2012 R2 PKI that allows you to issue certificates with an additional level of assurance in knowing that the certificate request was actually going to be from a device that has a TPM, and that private key will be protected by the TPM. This is really important today in our kind of mobile cloud world, where you know, the perimeter of our networks has blurred significantly, and it's going to be essential to verify and confirm identity. They say identity is the new perimeter these days. We have to know who the user is. Using TPM key attestation and certificates is going to be increasingly common. Certainly, Windows 10 client has some new features in Windows Hello and some of the other passport functionality that would leverage those capabilities. Finally, modern PKI and modern certificate services running on Windows Server 2012 R2 also supports something called short-lived certificates. There are a number of solutions that generate certificates in a rapid-fire kind of manner. They're not your traditional certificates that are issued for 6 months or a year or 2 years. They are short-lived, meaning that they last only for a few hours or maybe a day or two. Common workloads for that would be things like network access protection integration, so clients logging in via VPN, or even on the network needing to provide health status to a NAP infrastructure, use a short-term certificate. Direct access using one-time password or OTP authentication makes use of short-lived certificates, and with that, the Server 2003 infrastructure is not capable of supporting that. Fundamentally, what happens is it stores all of those certificates, and pretty soon you run out of space and processing power and so forth. So modern PKI infrastructure latest operating systems are much better suited to doing that. Now, with regards to Federation services, so Federation services is interesting in 2003. I can share with you from personal experience, the only thing I knew about Federation services in Windows Server 2003 was what I needed to learn to pass my MCSE for certification on Windows 2003. It wasn't really widely deployed. It was very, very new, very nascent technology. It was something that was quite immature, pretty rudimentary, and lacked a lot of fundamental support. One of the real challenges, I think, amongst many, was that it relied on IIS. It actually installed on top of IIS. Today, it's now an integrated server role, completely independent of IIS, so that frees you up from having to have unnecessary or unneeded services running just to support identity federation. Federation services in Windows, in the latest versions of Windows, of course, support SAML 2, which is a pretty common protocol that's used on the internet to do federation with business partners or with cloud identity providers, or with cloud service providers. For example, SAML 2 and things like that are used when you're doing Office 365 integrations and so forth. The Windows Server 2003 lacked any sort of capability, at least natively, to make the ADFS service available securely outside of the corporate network. And oddly enough, that's fundamentally what it's designed to do. And so the latest versions of course, Windows do have a fully functioning secure ADFS proxy. ADFS in Windows Server 2012 and 2012 R2 does include support for external authentication providers, group managed service accounts, which is an extremely important security tool. If you're not familiar with GMSA, definitely suggest that you bing that and spend a little time looking at that. Group managed services accounts, really a simple and quick and easy way to improve your organization's security posture. ADFS does provide support for basically modifying the look and feel of the login page to match your organization's theme. So in other words, you don't get the standard page. You can actually customize that and make it kind of conform to your corporate standards. And of course, Federation services are now highly available, or support high availability. In Windows Server 2003, of course, they did not. There was no support for ADFS web farms, which was a real serious limitation for enterprises. You introduce a single point of failure that can't be addressed. The modern solutions, of course, support that and work very, very well with the Kemp solution, which we'll talk about a little bit later in the presentation. Internet Information Services, or IIS. IIS has come a long, long way since Windows Server 2003. Of course, the threat landscape is dramatically different today than it was, 15 years ago, and IIS in Windows 2003 really reflected some of Microsoft's legacy thinking with regards to security, which was functionality before security. Functionality first, security second. Today, IIS now is fully modular. It supports a modular deployment. What that means is that in Server 2003, when you installed IIS, you pretty much got everything in the kitchen sink. The challenge there, of course, was that many applications were not using many of the features and many of the functionality that was actually deployed in IIS. And then, of course, when there was a vulnerability in one of those components that they weren't even using for their website or their application, they were exposed and sometimes compromised for it. So I think that with regards to IIS, the modular deployment's been a lifesaver in terms of reducing the attack surface and improving security. Back in the day, and certainly 2003 was early stages of IIS, not the earliest, but early on in the life of IIS. IIS was typically used to serve up fairly static content. It was a website, it was some web pages, perhaps some ASP to grab some information out of a database and display it, but it wasn't a terribly complex platform. Of course, today it is just incredibly mind-bendingly complex in terms of what you can do with it. They are full application platforms. I mean, you have to be an actual programmer to actually be able to work with a lot of these capabilities. And IIS does support and is much more extensible than it was certainly in Windows Server 2003. All of these things, when we talk about enhanced security, modular deployment, of course, is key in that. But there are also some other capabilities. So, for example, IIS now has request filtering built in. If you're running IIS on Windows Server 2003 today, you're probably familiar with something called URL Scan, which was it's a Microsoft software package, but it was an optional installable component in addition to. So you had to install URL Scan. Basically, that functionality is built into IIS now. IIS now supports delegated administration, which is tremendously beneficial, and centralized authentication and authorization. This is most helpful because we're seeing web farms that are supporting, hundreds or thousands of servers at a time to support some of these very large web applications, and being able to perform authentication and authorization centrally is obviously super important. IIS now supports better support for FTP. There was no support for FTPS or SFTP in IIS with Windows Server 2003. The latest operating systems fully support that inbox, so you can have secure file transfer traffic. And finally, and I think this is one of my favorite features of this, IIS is now supported on Server Core. Now, there was no concept of Server Core in Windows Server 2003, and introduced first in Windows Server 2008, and it's being enhanced in each operating system release. Server Core is tremendously helpful. It reduces the physical footprint of the device in terms of disk space. It reduces the attack surface greatly because we don't have a GUI on the platform. And of course, all of those are better for system startup, servicing, maintenance, and things like that. Much leaner, much better solution to run IIS on, absolutely. So switching to remote access, and this is a topic of this course near and dear to my heart. Remote access in Server 2003 was limited to basically the RAS service, the routing and remote access service that's been around with us for many, many years. I certainly remember working with it in NT4. I don't recall if that was in 3.5.1, but it might have been. It's been around for a long time, and Microsoft continues to make investments in this. If you're running RAS on Windows Server 2003, you're probably doing it with one of two protocols. That's either PPTP or L2TP over IPsec. I certainly hope that you are doing it with L2TP over IPsec because PPTP actually has been compromised, so nobody should be running PPTP anymore. And the problem is actually not with the PPTP protocol itself. It's actually with MS-CHAP v2, but it's not protected when you use PPTP. So there's a fundamental flaw in the PPTP mechanism that doesn't protect that. If you're not running remote access on the modern platforms, of course, you're missing out on enhanced protocol support. So with Windows Server 2008 R2, and certainly in Server 2012 R2, we have support for some new protocols that are much more secure, much more robust. That being SSTP, the first one being SSTP, which is the Secure Socket Tunneling Protocol. This is, for all intent and purpose, this is a client-based SSL VPN component. It's a part of the Windows operating system, so it's Windows exclusive, but it works very, very well. So it's supported in Windows Vista Service Pack 1 and later, and it works basically by using SSL and TLS to secure and encrypt our traffic from the endpoint to the gateway. All it requires is an SSL certificate installed on the remote access server, and your clients can take advantage of it. The drawback there is, of course, that it's not supported by any non-Microsoft platforms, and of course, it's not supported by anything older than Windows Vista with Service Pack 1. Remote access now supports IKE v2, which is probably the best protocol to use for remote access today, client-based remote access, I should say. IKE v2 supports a little bit better authentication mechanism. It also supports mobility, so it's a lot more robust when you're moving the client around. So, for example, if you have a remote access client connected via IKE v2, and it drops a connection, it will transparently reestablish that. If you pick up a laptop and you move it from one access point to another, it will reestablish that connection within a period of time. Direct Access is a new feature in Windows Server 2012 R2. Actually, it was around beginning with Windows Server 2008. It wasn't widely adopted until 2012 R2. But Direct Access, of course, was not available in Windows Server 2003 at all. If you're not familiar with Direct Access, I would encourage you to check this out. It provides seamless and transparent, always-on, secure remote corporate network connectivity, and it is bidirectional. It's an outstanding solution and one that I think many large organizations and even some small and mid-sized organizations would do well to investigate for their remote access needs. And of course, remote desktop has gone through a lot of changes and revisions and updates since 2003. The protocol itself, the RDP protocol, much more robust, much more secure, and secured by default. And also, the latest versions of Windows Server 2012 also have a support for a role called the Web Application Proxy, which did not exist in Windows Server 2003. This is a reverse web proxy, and it's used for publishing on-premises workloads, web-based workloads like SharePoint and Exchange and so forth. Finally, I want to talk about virtualization. Now, this is a really easy conversation to have because virtualization did not exist in Windows Server 2003, at least in the operating system. So today, of course, we have Hyper-V. Hyper-V is pretty ubiquitous. I'm sure everybody's familiar with it, but it is a proper Type 1 hypervisor. Type 1 meaning bare metal. It installs on the hardware. Now, if you're running virtualization at all with Windows Server 2003, it is likely with something like the old VMware GSX platform. Those were Type 2 hypervisors. Those basically installed on the operating system, did not run on the bare metal. They actually required an underlying operating system to run. These Type 2 hypervisors, of course, were nowhere near as secure or as robust or as performant as a dedicated Type 1 hypervisor. Now, with Hyper-V, of course, we can create virtual machines, we can create virtual networks, we can even virtualize our storage with shared virtual disks, do things like perform virtual machine replicas. We can replicate virtual machines from one host to another. We now have support for live migration. We can actually take a running virtual machine, move it to another host, without interruption to any sort of processing or networking. Tremendously powerful capabilities. Failover clustering is now fully supported for the workload, for the Hyper-V workload, and we now have cloud backup functionality. And I think this is pretty compelling because you know, using the public cloud as your disaster recovery point is becoming a pretty compelling solution. We now have integrated into the solution the ability to back up our virtual machines, data and applications, everything to the cloud, and do so directly from our Hyper-V servers. And of course, you know, Hyper-V is a pretty common virtualization platform, and one that is certainly gaining a lot of traction and pretty commonly deployed. Now, the good news is that the Kemp load balancing solutions can load balance any of the workloads that we talked about today, and can do so if they're running either in a physical or a virtual environment. It doesn't really matter to the Kemp solution. In addition, if you're a shop that's, you know, virtualizing everything, and this is becoming quite common, and you're looking to virtualize all workloads, including your security and your application delivery controllers, certainly you have the ability to do that with the Kemp solution as well. Kemp's available in the Kemp solution's available both in physical appliances and virtual appliances. And to talk more about that, I want to turn it over to Bhargav Shukla with Kemp Technologies to give you a little bit of information about Kemp, the platform, and the solutions. Bhargav?
Thank you, Richard. So yeah, I just want to go over a quick overview about Kemp and then provide some context on how we work with the different technologies you mentioned, Richard, in quite some details. So Kemp as a company has been in business since the year 2000. We are the application delivery controller, load balancer vendors. We provide the load balancer and relevant technology, providing the high availability, scalability, and acceleration, layer 7 functionality that most of the workloads need to be load balanced properly and achieve high availability, and then provide security using the web application firewalls. As a company, we have more than 26,000 worldwide customer deployments. Being channel-based, we rely heavily on channel partners and have more than 1,000 channel partners across the globe. 50% year-over-year staff growth and 46% year-over-year company growth are some really good numbers to soak in. From product perspective, what we offer is ranging from all the way to the left, the cloud ADCs, which work in Windows Azure, where you can go to Marketplace and deploy Kemp device with just one click. You can use it for your internal billing with Azure, or you can use the bring your own license model to use Kemp offerings to provide high availability in Azure, along with all the layer 7 functionality you might need for your applications running in Azure. When it comes to data center offerings, we have 3 of them. Bare metal ADCs are the ones that allow you to use your own hardware, whether it's Dell, HP, or others that we have certified, where you can practically just take our operating system and install it straight on top of your hardware. There is no hypervisor involved, and that gives you quite some performance that you might need using your own hardware that you might have. The other option is, I'll skip the virtual appliances for a moment and go over all the way to the right, which are the ADC hardware appliances. These are high-performing, dedicated hardware appliances that we sell. They come pre-installed, pre-configured with the LoadMaster operating system. You need to put it in your rack, wire, and network them, give them an IP, and configure it for a virtual service. So relatively straightforward setup, similar to the old way of doing the load balancing. It's a network device that you just put in your network. And then, of course, the one next to it on the left, the virtual appliance. Now, that is what is coming in from what Richard was talking about from Hyper-V perspective. The Kemp appliances have been around for a while now and are certified to run in production on Hyper-V or other virtualization platforms of your choosing. Kemp supports almost all major hypervisors that you can run our virtual appliances on, and we support them in production. So you could deploy the virtual appliances in your production workload and support and gain support from us as well. Can we just flip the next slide, please? In terms of looking at the Microsoft platform overall, looking at the big picture, Kemp actually works with majority of workloads that Microsoft has to offer. So looking at Exchange servers, remote desktop services, SharePoint services, dynamic servers, but then on above all, right at the operating system level, like Richard mentioned earlier, IIS, ADFS servers, federation services, direct access. Those are the different workloads that require high availability, and we actually work with them hand in hand with Hyper-V if you're running it on top of Hyper-V, or as bare metal, or the hardware solution if you're not virtualized. So that fits in nicely on the on-prem. If you are deploying your solutions in Azure, again, like I mentioned earlier, we have the ADC that runs natively in Azure, and that offers the high availability and layer 7, both switching and security functionality, content switching rather, and security functionality offered by WAF that you can leverage along with all the workloads you deploy in Microsoft Azure. We also offer geo functionality that is across the multiple sites. So if you have a primary site, primary data center, and you have a failover data center, for an example, you could use geo functionality to seamlessly failover in case of a disaster situation where your primary data center is down and you need to switch over your workflow to the secondary data center. Geo can assist in reducing that amount of time required, or even automate some of those functions depending on how you choose to deploy it. Let's go to the next slide, please. All right, so with that, I want to point out some very useful resources that we have that you can leverage to deploy your different workloads, such as federation services, direct access, remote desktop with Kemp LoadMasters. And it's worth mentioning that the direct access deployment, we worked hand in hand with Richard to both create the proof of concept, validate, and test our deployment to make sure that the Kemp LoadMasters are configured optimally and works as expected to provide high availability with direct access. So I got to thank Richard for his efforts on those, and you would see the fruit of his efforts in the direct access deployment guide. So if you want to check out all these different workloads that we support, the first link takes you to the resource library, and the other links are direct links if you're supporting any of those workloads. That gives you an idea of what we support today. If you see any resource that we support but don't have documentation you need, you can reach out to us. And then the last link I want to point out is for the free Kemp LoadMaster, which you can download freely from the website. It is supported in production, although you don't get a phone support with it. And there are some obvious limitations in terms of how much it can scale. But the functionality is not limited. So you can use it in proof of concept scenarios, in the lab deployment, even in production if it fits your requirements. So that's a nice handy tool to have. And then with that, we would actually like to go in demo. And so Kurt, take it away.
Hey, thanks, Bhargav. Let's just share this out. Okay, so we do have some time left. What I'd like to do is take you through a quick demo of deploying a LoadMaster on Hyper-V. So here we have our Hyper-V Windows 2012 R2. I've downloaded the virtual LoadMaster from the Kemp website, and I'm just going to walk you through setting it up. So we'll go ahead and import the virtual machine. We'll browse to the directory in which I downloaded it. We are running just downloaded the latest version, which is the 7.1-28A. What we're going to want to do is we're going to copy the virtual machine and create a new unique ID. We have the ability to change the location for the virtual machine files. We'll just keep the defaults for this demo. Same thing for where to store the virtual hard disks as well. This kind of just shows the summary. We'll go ahead and finish. Take this thing off. So the copy takes not very long, 15, 20 seconds or so, in which case we'll kind of go into the new virtual machine, tweak a couple settings, and then start it up, and we'll go right into the configuration. Okay, so we have it deployed here. I go into the settings here. One thing we're going to want to do is we have our network adapter, right? So we want to go into the advanced features here, and we want to set the MAC address to be static, and we want to make sure that the MAC address spoofing is enabled as well. We're just going to set up the one interface that's on the infrastructure switch for now. So we'll just hit OK, and we'll go ahead and start this up. Now, the infrastructure switch that we've set this virtual machine on is running a DHCP server on that network, so we'll be able to pick up a DHCP IP address from that network. But what I will do is I'll show you in the event that you don't have a DHCP, how you can kind of go in there and set that as a static IP. So let's let this finish booting. Okay. So we have, as you can see, our IP address here is 10.10.10.155, which again is from our DHCP. But what I'm going to do is I'm going to go ahead and log in. We also have the username and password, the default username and password, which will obviously need to be changed once we deploy this. But we can go ahead and log in with that account, BAL, and then the one for all password. And it's going to take us through a little bit of a wizard here where we can set the static IP address. We're going to keep the same IP for this demo, but you can change the gateway as well as the name servers for this virtual machine. So just go ahead and hit OK. What we're going to do now is we're going to, as it says here, to continue licensing and setting up the appliance, we'll just connect to our web user interface, which is on that IP address. 10.155. So we'll go ahead and continue. We will accept the user agreement. So we have a few options here for our licensing, right? So we can do a 30-day trial, which for this demo purposes we will. If you purchased the LoadMaster prior to running this and have an order ID, you can use that option. And then also, as Bhargav mentioned, we have also the free LoadMaster as well. But with the 30-day trial, all of our licensing is you need to register the product with our licensing environment. So everyone's going to need a Kemp ID to do that. If you don't have one, there's a link right here where you can create one. I, of course, have a Kemp ID. Oops. Okay, we'll go ahead and license that now. So it's going to reach out. You're going to obviously need to have internet connectivity from the LoadMaster to do this. And as you can see, it's been licensed, and we have, again, 30 days, so September 19th. What we're going to have to do now is we're going to have to put a new, as I said before, a new password. And I'm going to do something fairly simple. Oops. And of course, it's going to warn me that the strength is poor, but I'll continue because I'm going to end up deleting this machine anyway. And we have to put that password in once to get in. And now we have a deployed LoadMaster in Hyper-V. So it took us all of just a couple minutes to do. One additional thing I want to show you, we're talking about these workloads with Windows 2012 R2, is that we have templates when we're deploying our virtual services. So our virtual services are, the virtual IP addresses that you're going to be used for publishing whatever workload you're going to be publishing. So we have some templates that we can import. So we'll just import a couple. We have an ADFS template, so we'll add that. We have desktop. We can add that. And again, we have other ones that are all available on the Kemp Technologies website. But we can go ahead and add these. So now, with these templates, when I go to add a new virtual service, I can select these templates to do the majority of the configuration. Now, you're still going to want to leverage the deployment guides because it doesn't have all of the settings that are required, but you can use this in conjunction with the deployment guide to kind of just make that configuration much easier for you. So that leaves us with about 15 minutes to kind of get into some Q&A. Roger, I'll pass it back to you.
Well, thank you, Kurt. We do have about a half a dozen questions that we will dive right into. So I'm going to just go ahead and throw these out. And again, I'll encourage everyone to forward any other questions or comments you might have, since we have some time to take those. We'll not be identifying people by name on their questions, so if anyone has concern about that, we're just going to throw the questions out here to our speakers, and so anyone feel free to jump in on a response. First one is there a limit on virtual network cards when using the Kemp Virtual LoadMaster in Hyper-V?
Actually, this is correct. So yes, there is, and those limits are imposed by Hyper-V, right? So Hyper-V has a limit of a total of 12 network adapters. You have the 8 network adapter types, and then you also have an additional 4 legacy network adapters. Kemp recommends that you use the network adapter for better performance, but again, that limit is based on what Hyper-V limits.
The second question is, does Windows Server 2003 support version 3 certificate templates?
It does not, and that's an excellent question, by the way. So for customers who are still on Windows Server 2003 that are needing to support modern cryptography, so cryptographic next generation or CNG, any of the Suite B algorithms which use elliptic curve cryptography, which again are the highest, at least today, the most secure form of cryptography, those do require version 3 templates, which were not introduced until Windows Server 2008. So if you are still running PK on Server 2003, then that becomes a real issue for you.
All right. Next one is, can I just use Kemp as a reverse proxy for ADFS rather than deploy the web application proxy?
Okay, so you can.
Just Bhargav, yeah. Kurt, go ahead. Sorry. No,
go ahead, Bhargav.
All right. So the ADFS, there are 2 pieces to that puzzle. When you're load balancing your Active Directory Federation services, and you're not using any advanced claims like you can in certain scenarios where you want to restrict users coming from certain IP addresses and so on. Any of those advanced claims requires web application proxy to be deployed. In any scenarios that do not use those advanced claims, they can use Kemp LoadMasters instead to pass the traffic to the backend and act as a reverse proxy to ADFS.
Okay, next question is, can I use the same LoadMaster to load balance the ADF servers and the web application proxies?
Okay, I'll take this. Sure. Yes, you can. You can definitely, since we have multiple interfaces that could be, or network adapters that could be added to either the virtual LoadMasters or even multiple adapters on a physical LoadMaster, you can definitely have those. And now, obviously, the web application proxies typically live in the DMZ, and your ADFS servers typically will live on the inside. So it really becomes, whether or not that is the environment you want to have. A lot of our customers will deploy a set of LoadMasters in the DMZ to load balance the web application proxies, and then they'll do another set of LoadMasters on the inside to load balance those ADFS servers. But technically, it's doable.
And the last question that we have is, does direct access require IPv6 on the corporate network?
It does not. So this is a common myth and somewhat of a fallacy, is that many folks who are looking at the direct access, remote access solution hear the word IPv6 somewhere and begin to panic because they don't have any experience with IPv6. It was true with the first iteration of direct access. So when direct access was first deployed in Windows Server 2008, it did require IPv6 on the intranet. However, beginning with the forefront UAG Windows Server 2008 R2 direct access model, the UAG actually included some IPv6 to IPv4 translation technologies, which eliminated the requirement for IPv6 on the corporate intranet. So, and of course, today we recommend that you deploy direct access using Windows Server 2012 R2, for which those IPv6 to IPv4 translation mechanisms are now a part of the operating system. And just a point on load balancing for direct access, and you'll notice this in the direct access deployment guide, is that load balancing the direct access workload is actually fairly straightforward in terms of since it's IPv6 traffic from the client to the server, we're using an IPv6 transition tunnel, and in this case we're going to use IP over HTTPS, which is really as simple as load balancing a web server, so it's fairly straightforward.
Well, On behalf of WindowsNetworking.com, I want to thank you, Richard, and Bhargav, and Kirk, and for a wealth of information today. And I want to thank all of our attendees for joining us today. And of course, we want to thank Kemp Technologies for making it possible for us to bring you today's webinar. The recording of today's presentation will be available on the WindowsNetworking.com site very soon, so watch for that. And this will conclude today's webinar. Thank you again all for attending, and you may now disconnect.